Okay, so the Doppler effect refers to the change in wave frequency during the relative motion between a wave source and its observer. This basically means that as a object gets closer to an observer, the frequency of the sound waves or light waves being emitted by it will increase, meaning that the pitch of a sound will increase. This was actually first discovered by a woman named Christian Joanne Doppler, who described it as the process of increase or decrease of starlight that depends on the relative movement of a star. This is obviously not sound, it's more light, but it does apply to both. The Doppler effect works in sound because when an object emitting sound moves towards the observer, the frequency of the sound waves reaching the observer increases, which leads to a much higher pitch for the sound. But it does the opposite when it's moving away, as the frequency of the sound waves actually decreases and the pitch goes down. Some ways that the Doppler effect is actually used today is sirens, astronomy, radar, satellite communication, and audio. A few of these are kind of self-explanatory, like sirens and audio, because you have to account for the Doppler effect or use the Doppler effect in order to actually amplify. But other ones like astronomy are not as clear, but astronomy, it's helpful because the universe expands as a consequence to the Doppler effect. But then the other ones, such as radars and satellite communication, they are in terms of waves. Okay, so the setup of our system is a playing card that has been taped to the frame of a bike, and then stuck between the spokes of a wheel, which basically means that the card will click down every single time that it's hit by the spokes, which means that as the wheel turns, it produces a sound that is observable by us for our experiment. In this experiment, the sound will be moving and the observer will be actually standing still. In this experiment, the sound will be standing still and the observer will be the one who is moving. In this version of the experiment, both the sound and the observer will both be stationary objects. In this version, the observer and the sound will be moving at the same velocity.
In conclusion, our example shows the Doppler effect because the pitch of the card gets higher as the bike gets closer to the observer, and then as the bike gets further away, the pitch of the card gets lower.